So now we're going to graph each of these transformation, okay, one by one of this parent graph. Just remember that any of this could be a parent graph and can be transformed in the same way as long as the base, okay, is positive. That is your restriction. The base is positive. So now let's start to graph our parent graph. We said the points of this are 2, 1, and 1/2. So let's graph it here in our x and y axis. So we say when x is 1, y is 2. When x is 0, y is 1. And when x is -1, y is 1/2. That is why this is the graph of y equals 2 to the x. This is the parent graph. Now you should approach, okay, do not touch this. This is an asymptote. That means you will never have a negative, okay. Just as a review to remind you, so when you graph this, just try to show me that you are graphing the asymptote, and that is the line y equals 0, the horizontal line y equals 0. Now why is there an asymptote? Because like what we said, our equation here is y equals 2 to the x, okay. If you give negative values, okay, x becomes, will there ever be a value of x so that the y will be 0? You cannot give any value for x, right? Because 2 to the 0 is 1. Okay, what about what value of x will make this negative? You cannot, because -1, okay, so there is no value that will make that 0. Will there be a value that will make that a negative number here? No, because 2 to the -1 will become a fraction. So there is no value of x that will make 2 to the x equal to 0 or a negative number. That is not in our range. Okay, so the domain here, you could give any number for x, so your domain here will be all real numbers, but your range, the value of y, can only be from 0, no, not 0, so this should be a parenthesis, 0 to positive infinity. Okay, so again, let's write that down here. So let's say domain y equals 2 to the x. Domain is all real numbers. Range is open, 0 to positive infinity. You could also see that from your graph, right? Okay, your domain is left to right, but your range is above 0. Okay, so now let's graph the first 2 to the x plus 3, 2 to the x plus 3. Okay, so what is the graph of 2 to the x plus 3? Okay, we said that's going to go 3 to that, translate 3 up. Translate 3 up. Okay, so we're going to translate these 3 units up. Just so this is y equals 2 to the x. Okay, that is our parent graph. Just concentrate on these 3 points, and we're going to move these 3 points 3 units up. So 1, 2, and 3. So we are here. Okay, you move it 1, 2, and 3. We all know how to translate. Okay, and then this is on the 1/2, so we do 1, 2, and 3. So we are just, okay, moving this up 3 units. Okay, and we remember the graph of exponential includes the asymptote, okay, for some of you. Okay, this is the asymptote. Okay, a line where your graph approaches closer and closer and closer but never touching it. Okay, so your value could be 0.000001, but it cannot be 0. Okay, so that is called the asymptote. Now this is our graph. Okay, and of course we have to move also our asymptote 3 units up. Asymptote is part of your graph. Okay, so here, so this is the graph of y equals 2x plus 3. So your domain and range is this. Your domain is now different. And now your domain is all real numbers. Your range will now be from higher than 3. You cannot go lower than 3. So parenthesis 3 to positive infinity. And your asymptote is y equals 3. Is the line y equals 3. Okay. Now, let's go to the next equation will be y equals 2x, but the plus 3, you add it to, here you add 3 to the parent graph 2 to the x. Here you will graph 3 only to x. So this is a translation 3 units to the left. Okay. When you add a number to x, then that's either left or right. When you add a number to the parent graph, that is up and down. So we're going to move, okay, so we're going to move the parent graph 3 units, or 3 units to the left. It's 3 units to the left, not the right, the left. Okay, so we're going to move this 1, 2, 3. Okay, let me just erase what I wrote here, and I will write it somewhere else so we can see our graph. Okay, so y equals 0 is our asymptote. That is called our asymptote. Okay, so now let's move the parent graph 3 units to the left. 1, 2, 3. This point 1, 2, 3. This point 1, 2, and 3. And this line, we will move it to the left. It will stay the same. So this is now our graph. Okay, it will go up there. Okay, let's use solid. We always use solid. Actually, we should use red, but okay. Alright, so this is now the graph. Y equals 2x plus 3. Domain is the same. All real. Range is the same. 0 to positive infinity. And asymptote is still y equals 0. Okay, and let's go to the next in our list. Negative. What about if we now have negative 2 to the x? So we said that that is going to this one here is going to reflect across the y-axis. So let's reflect our parent graph across the y-axis. Okay, so a mirror image. So 1, 2 up, 1, 2 down, 1 up, 1 down, 1 half up, 1 half down. Okay, and then we will also reflect our asymptote on the x-axis on itself, so it will stay the same. So this is now our graph of y equals, okay, y equals to negative 2 to the x. Okay, let's write it here. Y equals negative 2 to the x. And what is our domain?